And that's at the same place on the ground. Little islands left. And the challenge in rehabilitating that would be to reconnect those islands and make a whole lot of little ponds that'll end up restoring the surface and the productivity and leach down the salt. So gullying occurs in areas of stronger flow, and what I was just talking about there is sheeting, scalding in areas of gentle flow. But very rarely is wind the only cause and driver of scalding and sheeting. Water erosion is often the case, and especially in floodplains. And then something I didn't come across very much until I got to Western New South Wales is excessive deposition problems. And this is a property between White Cliffs and Packsaddle that Paul and I are working on. And the string of waypoints up the top there from 17 to 6 is a gully head that's moved about 2 kilometers in 40 years. And in the middle you can see waypoint 2 is the river that's now blocked up and sending water straight to that gully head. And there is what used to be a floodplain. All the gum trees and other tall scrub is dead. The water is just not going to the floodplain anymore. I'll talk briefly now about causes of gullying as opposed to accelerators. Many people think of gullies as being caused by excessive flow. That is the accelerator pedal. It is not usually the start of the gully system. Nick points are the start. So anywhere where the land is cut, station tracks, main road culverts, and I worked on one near Burketown, fixing that problem up. Animal pads, and Paul will talk a bit more about this, but anything that cuts the land surface and drops the base level initiates a gully. So water flows downhill. That's pretty obvious. There are exceptions, but let's not worry about that detail. Erosion proceeds uphill. Gully erosion proceeds uphill, but even sheet erosion, those little waterfalls a centimetre high, they go uphill. And of course, the topsoil follows the water downhill. There's a diagram at the top, point X to Y, classic schematic of a gully head. The fingers all pointing to where the water is coming from. Each little finger is a thief of water more than soil. Soil, yes, obviously a problem, but the impact of dehydrating and drawing water is ecologically and commercially at least, if not more, important. Down the bottom, you see the same diagram, the cavitation, caving, and that's how the gully head proceeds upslope as the top gets too heavy because of the caving, the cavitation cut below. So it's really important to understand that nick points start gully erosion. Overgrazing, etc., is the accelerator pedal, not the cause in most cases. And that's what you end up with. Instead of having tributary, keyline, distributary, and then your bottomlands, you end up with a canal to the coast. And there are far too many catchments in Australian rangelands or the outback that are like that. But it can be fixed, and Paul will talk to you more about that. So in summary about all the bleak story, upland valley floors are breached and leaking, key lines incised and not functioning, so no distributary flow. Valley sides essentially become like a canal system or a drain system, and floodplains are stripped, perched above the expanded and lower river channels, creek channels, and thirsty, like the whole catchment. The whole catchment starts acting like a hill slope, and all the jewels in the crown, the little wetlands right from the base of the hills all the way to the flood and into the floodplains are drying, and either thickets or just scalded salty soil. So let me just drill down a little bit into the floodplain perspective of this. So your primary base level is either a salt lake or your ocean or whatever. Your second is the base of your major channels, your major creek beds and so forth. And there we have a typical pattern. On the top is healthy, where a rock bar or whatever it is holding up that section, that segment of the catchment, and causing floodouts in reasonable rainfall events. And then down the bottom, the base level is down. The river gets wider and deeper. Water tumbles now. When it can get out, it tumbles back and starts gully erosion. There's an example, a real example from the Murchison with my mentor, Ken Tinley. That where he's got his hand was the old base level. So it's about 3 meters deep, and that's caused erosion all through the Murchison. And there we are, upslope of that. And Ken's showing the baseline where it used to be on the tree. And there's an example with the water flowing right to left. And you can see that on the scour bend where the floodplain water has tumbled in, the water has caused a gully to start at the scour bend, and it's cut out the billabong, which you can see from the gum trees. It's now just a continuous channel. And they're wider. The whole floodplain system is entrained in stripping to that point where the water's getting out. So you guys have two problems. You've got this problem for small flows, and you've got too much water with those massive floods. It's a terrible predicament, and I feel for you there. And there's an example on the left is the cobra about to strike, or the taipan about to strike the billabong. And that's coming off the Murchison. That in a few, I don't even know if that billabong exists anymore. That gully head is going to take it out if it hasn't already. So you have to understand that once the water tumbles into and starts a gully head at the bottom of in the valley floor, maybe the major local creek or the river, that erosion doesn't stop until it hits the rock. It keeps cutting and splitting and cutting through all the key jewels in the crown. And that's just an example at the top of a really healthy little local wetland held up by a soft sediment sill, and then often cattle pads, more than sheep, cattle, because of their single file padding from water point, wet spot to wet spot. They've cut through the sill in the middle, and eventually they get through to the inflow to the wetland, and it all just becomes a big thicket, and nobody knows that it was once a beautiful wetland with a little aquatic system in the center. And there's an example from the Murchison as well. of a cattle pad coming through there on the edge of the floodplain. And that's an example of on the edge of the floodplain, not a billabong, but on the edge of the floodplain before the flood out starts. A wetland just about to become a non-wetland. So what do we do about it? And I'm going to focus on gullies and their channels. Paul will talk about the wider context. So there we see that one of the major problems is that the channels got deeper and wider. They have much more capacity to hold all the small flow events, and nothing gets out on the floodplain until all of a sudden, whoosh, you get the massive floods and the land is not prepared for them. And I saw that when I was working around Burketown and Normanton. One of the things we've done is put drill rods in where we've got rock bars, and they've been astoundingly successful in raising the base level and getting the water back out on the floodplain. See, we put a series of 5 just drill rods. The pastoralists who did this in the Gascoyne said you only need 3 lines maximum and cut them off at 1 meter. You don't need any more than that, and just use the landscape level to work out how high they need to be, but incredibly successful. This is work I do in Namibia, in the far northwest arid part of Namibia. That's Kombombo, myself appointed offsider. He's standing in the old road from the regional capital to the national capital, which is now a big gully. And we've put a suspension filter. Can't put stuff on the ground there, it'll just wash out. So we hung cables across all the way up at key places. And now the water is heading, instead of heading straight past him past the borehole you can see in the back with the water tanks, it now heads off to the right and back out into its natural flood out course. Elsewhere, this is near Udnadada. We've put a floating drop structure in. Floating as in we've put geotextile underneath in a trench and then built that structure, which is also got geotextile armored with crushed limestone, and essentially re-raised the base level back to natural height. And that's a pretty ordinary diagram that I did this afternoon, but showing you the trench underneath, tucked in with the geotextile, and then you build the bank and cut the notch, put the geotextile on top, tuck it in as well, and then cover it with limestone, crushed limestone, or any other suitable material that doesn't break apart when it gets wet. But it's really important, especially for you guys, not to be kicking water out of your channels and your gullies when the reception is a gully head itself. Otherwise, you're just going to link up all your problems and they just become a bigger problem. So there you have a very small, low gully head with the water tumbling in, and then it just collapses and cuts back. You see some of the clods that have fallen in. They're looking upslope at another one that we dealt with near the Flinders Ranges in South Australia. This is a slide that Paul annotated, but essentially you see the gully head, and we've put Big Bertha, that's its nickname, at the top there to stop it. and then caught that water straight away and spilt it onto a clay pan. And then we've got a series of champagne banks, cutting off all the lateral gully heads until the water goes away. And this is something that I know from working up there might have some value, but you're going to have to oomph up your banks to take the big flows and make sure you're not spreading it to another problem. You can see at the top of the photo on the right-hand side, Paul's ponding work, and he'll talk more about that. Here, we've basically drowned a gully head. We smashed its head down and then put a keyed-in drop structure. So we didn't have a trench and geotextile. We just cut a trench, deep ripped it, and then used limestone. So the notch is just really hard rolled, watered limestone, and we've just drowned the gully head. In Africa, in Namibia, we've used cattle to smash down the gully heads, keep them in for 3-4 nights, let them out every day, and then put them in until we're happy with what they've done, and then lock up the kraal again. With low gully heads, we just deep rip. This is in the Flinders Ranges near Hawker. Yeah, we just ripped the heck out of the little low gully head, a maximum of 1 foot. And that is right near the main road from Hawker to Blinman. So I've checked it out and it's still perfectly stable and adequate. And yeah, there is the water's coming towards us, a different approach where we've simply bashed down the gully head, and then we've essentially made a contour aligned. So I did the surveying, contour aligned potato field. It just ripped, so that any water coming to where the gully head was has got to go through all those water calming, absorbing sponge rip lines, and we'll get massive recruitment of perennial pasture, and the pasture will do the job. Getting towards the end, prevention is obviously more better than cure, and Paul will talk a fair bit more about this. But one of the key issues is not to start nick points. Don't cut your land, and do your management, your grazing management, your fence lines, your watering points, your tanks, your dams. They must all fit the landscape to prevent cutting the land. Cutting the land is the cause of many of the problems. In a concluding comment, prevention first, so lift the blade, spread the load when you're driving, make your roads wide enough that you don't have to end up with wheel ruts, locating waters, etc. I'll hand that over to Paul. Sequence works to minimize damage. Don't kick the water out of a gully and send it straight to a gully head facing straight at where you're sending it, as an example. It all goes together. So fixing erosion is a waste of time if you don't put it into the whole management plan and do everything that the landscape needs to make your landscapes healthier and to make your businesses better. Erosion control on its own is no silver bullet. And finally, learning from your mistakes and skill up with every lesson learned. Share your learning process. Don't be afraid of making mistakes. You will make mistakes. Just learn from them and share them with your local community. Now, I might finish there. Thanks, Anne.
Thanks, Hugh. Thank you. I am conscious of time, Do we want to have some questions or discussion on that before we move on to Paul? Comments, please. Questions? Discussion?
And Bob here, I've just got one question to Hugh about deep ripping. I've done a lot of deep ripping. I find it works very well on soils except those that are deep black cracking clays. I find on the deep black cracking clays, the rip lines last till the first rainfall event and the rip line is effectively gone. Hopefully in the meantime, something establishes and you get some benefit from the ripping, but I find the longevity of deep ripping on cracking clays is very short. The longevity on non-cracking soils is quite good. So I just wonder if you want to comment on that, Hugh.
Can you hear me, Bob? Okay. Yeah, no, good point, Bob. And absolutely, as well, it's a waste of time deep ripping sands because they'll blow away or they'll collapse in. And sometimes you have to acknowledge that you might need to rip 2 or 3 times. And because they do collapse, and sodic soils also collapse. So it's really a risk. It's a gamble about when the rain's going to come, what kind of rain and what species will grow. But ripping on its own is not necessarily a panacea. I'd normally link it to something else. And with cracking clays, you've got to bash the heck out of them before you do anything with them, if you want to do earthworks with them. I don't know if I've answered your question properly there, Bob.
Hello. Any other questions to Hugh? Hello. Well, Paul, we'll hand over to you then.
Okay, so I need to get my presentation up. How do I? Oh yeah, here we go. Right, so is that coming up on people's screen?
Yep.
Okay, I'm just trying to get the slideshow happening. Here we go. Yeah, so I'm sort of following on from Hugh. There's a lot of overlap. So I'm sort of looking at slowing the water that's going to the floodplain. So I'm looking at sort of maybe in the upper catchment areas. So yeah, so everyone can see that now. Yeah, so I'll be looking at the repair options for the upper catchment, and also I'm going to be looking at ways to mitigate erosion damage or that prevention thing. So some of the things that we can do to just stop it from happening in the first place. So erosion gully in a valley side. So in that photo there, you can see the floodplain, the main floodplain in that area. And you can see that valley side coming in and goes in nice and slow until it hits that erosion gully and it's gone. So like Hugh was saying, they're just downpiped straight into the floodplain. So how do we sort of approach that? One way we've been looking at is, one option is water spreading with diversion banks. So that diagram there, you see the gully coming down the center with a bank built across the gully, which is taking the water away. And then the banks are pushed uphill, exposing the channel, and then that way the water can actually spread out. So that channel is basically on a contour, so you're able to spread the water out on a broad front. But a few things with this system, like everything, there's areas that you use it and areas that you don't use it. So the area has to be even surfaced. It can't be bumpy. It can't have rills going through it. Low slopes, so anything 1% and lower. And Hugh talked about the key line where it becomes a distributary sort of flow. That's where these banks work, where the water naturally is trying to spread out. This system helps it to spread out. And small catchment. So I've got there 500 to 1,000 hectares. That depends on the type of catchment. If it's a very fast catchment, I'll be looking at the lower figure. These structures can't handle massive flows like Hugh had that big check bank with the champagne banks in his presentation. They can handle a lot more volume. These are a little bit, that's why it's sort of used more in the upper catchment. This is just an example of where we've used it in a side valley. So that erosion gully was going straight to a major channel, major flow line. So we've put that diversion bank there where that thick blue arrow is, and then the bank changes over where those dotted lines are, and it spreads it out onto that floodplain. So that's just an example. Those other horseshoe shaped banks, I'll talk about them in a minute. They're the water spreading banks, but they're used in conjunction with what we were trying to achieve in that project. So once the water's out onto that floodplain, that's a picture of it there. There's a main channel. There was also breaks in the natural levee bank, which needed to be plugged up so the water didn't go straight back into that main channel. The main channel is basically acting like a gully, stormwater drain, just taking the water out. So that was the multiple techniques there that we were using. And obviously where you actually apply those techniques needs to be carefully analysed as well. It's just not across any gully. Just another example, an erosion gully further up in the catchment. We did the same technique, but this way we just use a series of water spreading banks. You can see them in the photo there. So that dotted line represents the gully. That gully pretty much went right to the top of the hill, like it worked its way all the way up. And so we've put in the diversion banks there and then the water spreading banks out there. So you can see the water flow, and we've spaced them out at a distance of about 200 meters. It was just sort of based on where that water was just about to come back into that gully. We put another one in just so that water stays out and doesn't come back into the gully. And that's what it looks like on the ground where it actually intercepts the gully. And that's this area where it's spilling out on a fairly broad front, a couple hundred meters. So scalds and sheet erosion. And this is a photo sort of showing the sequence of events. So on the left-hand side, we've got the healthy plain where you have meandering water flow. Then you've got what I'm calling the stripping zone. Water starts to straighten up and go fast, and then you've got the scald on the right-hand side, and that scald continues to move to the left up through that stripping zone and into that healthy plain. So it continues to expand. And well, that's just the scald on a windy day. They're not very nice places to work, but all that water, well, yeah, like you were saying, the wind erosion sort of happens once it's at that level. It blows a lot of dust once it's eroded down to that subsoil. And then, yeah, so all that water's going to that drainage line. None of the water's being held up higher into the landscape. So the idea is we're trying to keep the water as high as we can in the landscape rather than letting it just to flow out through the drain pipes. So we're using a technique called water ponding. A lot of people have seen that. Yeah, Ray Thompson from Ningen has done a lot of work with water ponding. So with water ponding, it's important that you start at the top of the catchment. These banks aren't designed to receive high energy water or very deep water. So that they're designed to start at the top of a catchment. So you're starting right at the top. So the water isn't angry yet. You're ponding at about 10 centimeters depth at the deepest. And the area is no more than half a hectare. So the ponds in that photo are obviously not half a hectare, but you don't want them to be more than half a hectare because they just get too big to manage. The risk of breaking is a lot greater, and wave action. So when the ponds are full and there's wind blowing, it actually creates quite large waves, and that just eats away at the bank. So you don't want it to be too big. As you can see, the ponds spill out both ends. So the spill points are very important to sort of locate. You don't want them to be located next to an area where it'll compress the flow, the spilling, to create more energy. And bank heights, we've found that they need to be at least 50 centimeters. That allows for slumping. But again, that depends on soil types. If you've got really hard setting soils, they don't have to be finished at 50 centimeters. But if they're sodic or soils, then yeah, 50 centimeters is the minimum. And build them from either side. Like we've been building them from the downhill side. So when it does rain, it ponds straight away. So that's sort of in the arid zones where rainfall is quite sparse. We want the water to pond fairly quickly. Whereas in high rainfall areas, you can build them from both sides, inside and out, like that bottom photo. And that allows for a bigger bank to be built, but it also requires more rain in order for the pond to actually fill up. But yeah, higher rainfall, I'll be building them from both sides. And with the ponds, we're also seeding them with old man saltbush or perennial grasses. So whatever is native to your area, they're ideal opportunity to use the actual ponded water as an opportunity to seed with something. And after a few years, that scald becomes a cracking clay soil again. It's amazing to see how it changes the soil so dramatically. So when contour furrowing is another thing we use higher up in the landscape as well. That's a fairly simple operation. It's a one pass with a machine. It could be rippers, it could be a blade on a grader, it could be a moldboard plough towed behind an old tractor, just anything. And you can see that little diagram there, leaving gaps in the furrow line, staggered, so the water sort of meanders through. We use that when the slopes are a bit steeper than 1.5%. That's sort of the time we sort of start looking at contour furrowing in the upper catchments. So yeah, the whole idea of all these techniques is just to hold the water as high as possible, just slowing the water to the actual bottomlands. I've got here clearing. I'm not sure what the legislation is in your area, but in Western New South Wales, chaining is an option. And when you've got broad areas of just sheet eroded country, leaving the scrub on the ground is actually a very good repair mechanism. It presents other problems, but just as a way to stop sheet broad scale sheeting, it's a quite a good method, as you can see in that picture. So it's something that you could consider. So just those little wetlands that start way up high and work that, and you have them going all the way down the systems. Yeah, Hugh talked about that. He's had a similar photo, but yeah, there's one there ready to be dehydrated. So some of the repair options. We've been using soft filters, so whether that's shrubs or netting anchored with rock. So this is a picture from Hugh where there's a wetland in the background there and just a whole heap of shrubs and timber that have been anchored down with steel pickets just to keep them in place. And that protects that soft rim from getting eaten down or eroded down by stock padding over it. So that's one way. And another way is that, netting, which is anchored with rock. So these systems require a little bit of manual labor. But yeah, it's a way to be able to protect those soft sills, and it works pretty well. So that's for those little ephemeral wetlands, those clay pans all through that system. So I'm going to talk about mitigating erosion damage. Like this is sort of like that whole prevention. So Hugh's mentioned these nick points, and it's all about preventing those types of things occurring. Erosion along tracks and fence lines. Like I know that's, you guys have been exposed to Darrell Hill up there, and it's amazing at how much damage is caused by tracks and fence lines. So in that photo there, like that dashed line represents the original flow path, but it's changed, that road has changed that sheet flow into a concentrated flow, and it's taken water away from the landscape. It alters the course of the drainage line. So what do we do in these situations? So this is something actually Darrell often asks. He says, you see a road that's been eroded away or whatever, and you say, is the damage caused by the flood, or was it inappropriately designed and built tracks? So that's the question. Was it the flood that caused it, or was it the track that was not built correctly? So this is an example where there was a flood, and after that flood finished, that was their driveway. That was their main driveway into the house. So obviously not anymore. So did the flood cause it, or was it the road inappropriately built? And you can see it punched through that sand dune because that sand dune was lowered. And now that's the new watercourse for that creek, or when the creek reaches a certain height, that's where it goes now. But anyway, so what are some of the ways you can sort of mitigate against that? So this is by no means an exhaustive list. I'll just go through it, very quickly and briefly. So grading to a minimum. You don't have to cut the ground, but just minimum. No windrows. Windrows are a big issue as well, diverting overland flow. Track placement. One of the worst spots to put a track is parallel to a drainage line. So don't put a track parallel to a drainage line. It picks up so much water and creates a secondary creek. And that's similar to that photo. That's what's happened there. That's parallel to that creek. So when crossing drainage lines, make it perpendicular, make it as close to natural ground level as possible. And if you need to put gravel there, cut away the soil and fill it with gravel rather than putting the gravel just on top of the ground level. It all takes a lot of work, but it prevents the start of gully erosion. And then drive over banks or woe buoys. If you really want to deal with erosion along tracks or fence lines or anything, pipelines, there's going to be times where you're going to have to put a drive over bank on the road. You just can't get away from it. So for example, with that photo there, like ideally what needs to happen there is a bank put where that sand dune was blown out. Like you can't reinstate that sand dune as it was, but at least it has to be at that height. So banks have to be part of the whole option there. And this is a fairly typical way of how I do it. Again, the Darrell Hill method, where there's a borrow pit where that water's sitting, and that's where the soils come from to build that woe buoy. And that borrow pit is also surveyed in at a level point on the downhill side. So when that fills up, it spills out on a level sill of about 10 to 15 meters wide. So it spreads the energy. So that's one way to mitigate erosion along tracks and fence lines. Water points, or the placement of water points. Another cause of erosion. So in there, you can see each of those dotted lines is a stock pad coming in to water. And that's what it looks like on the ground. So little gullies coming in all over the place into the water point. So the ground tanks have got to be in that part of the landscape because that's where you need to collect the water. So you can't really necessarily move that ground tank, but you do have the option of fencing off that ground tank and piping the water to a more stable area. I mean, that is an option. You couldn't do it to every single ground tank, but some of the really sensitive ones where there's a lot of erosion or it's affecting really good country, yeah, you might think about doing something like that. And invariably there'll have to be some type of soil conservation earthworks. Again, it'll be unique to each situation. But yeah, placing water points in valley floors is a really, yeah, it's a spot that can be really easily overcome with erosion. Another thing with, oh, sorry, this is just a, yeah, stock pads coming into a water point. All that soil's got to go somewhere. It either, well, it fills in all the little ephemeral wetlands and the clay pans on the way to the water point, and then it ends up in your water point. It's just, yeah, desilting ground tanks. That was meters and meters deep, that silt. But another placement of water points in creek lines. So in this situation, where you have a ground tank that's in a creek line and it intercepts the entire flow of the creek, it's not ideal, because what happens is you've got to deal with the bywash water. And this is a situation where this particular ground tank was intercepting, well, 5,500 acres of catch, and that's how much water was coming down. And that photo is the bywash water. So after the tank filled up, you've got to do something with that water, and it's a real headache to do that, to do something with that amount of water. So an alternative would, again, this could be an alternative, is to use the side catch. Not as big of a catch, but you can put diversion banks and just divert some of that red area, and then that way you still got a fair catch, filling up your ground tank, but you're not dealing with huge amounts of water like in that photo, which that causes all sorts of erosion issues, that type of water. So just a little bit on just ground tanks. This is just a diagram to illustrate some points that I'm going to make, and this is a topic in and of itself, ground tanks. Some of the issues around ground tanks, three main issues that I've seen causing lots of erosion damage. The first one is diversion drains. So that they're the drains that are going into the ground tank to fill it up. Oftentimes there's just way too many of them. Like they're cutting really, really deep as well, and they're too steep. So when the water gets into those drains, because they're so steep, the water speeds up and creates some really big erosion gullies. And they're a big problem. So diversion drains need to be surveyed in at a certain gradient, and it's not by eye, they've got to be surveyed in by a level. In this area, we survey them in at 0.2% slope, which is 20 centimetres rise or fall every 100 metres. So it's not a very steep slope, but it's enough to keep the water moving, and slow enough that it doesn't create a nick point. It doesn't actually initiate any erosion. In higher rainfall areas, you'd change that slope to be steeper, but not massively steeper. But in Western New South Wales, we use that 0.2% slope, and it works. And the drains have got to be as broad as possible, not really sharp V drains. The other issue with ground tanks is the bywash or the spillway. Spillways have to be located so it's in a really flat, broad area, not where the water will concentrate. So in that diagram there, I've got it spilling on both sides of the tank, and that way it spreads the water as well, rather than just spilling on one side. But again, that's location specific, but it's just trying to illustrate the point that you've got to have a designed spillway. Otherwise it causes erosion issues as well. And the third issue is the freeboard. So that's what, once your tank is filled up and spilling, on that back wall, you've got to have a bare minimum of 1 metre height. That's the bare minimum. But it needs to be ideally 2 metres height, a 2 metre freeboard. But that's a fair bit of soil to get that. But if it's any less than 1 metre, the back wall just gives way. Like the water coming in, it just surges over that bank and then creates a nick point, which just creates a massive gully as the water just empties out of the tank there. So they're the three big issues. And again, you could spend a little bit more time on each of those issues, but it's just sort of being just raising a bit of awareness. Those three issues for ground tanks need to be really considered. So ground cover. Now, grazing management, we all know that it's important, of course, but like Hugh was saying, ground cover, overgrazing is the accelerator pedal. So with good ground cover, everything slows down. Water flows slow down and erosion slows down. So that's a good enough reason to have good ground cover. But also, when you do have earthworks, good ground cover takes the pressure off those earthworks by slowing everything down. But another point is, not every degradation issue can be mitigated using landscape engineering techniques. So all those techniques that I've just been talking about, that's not a silver bullet for every degradation issue. Sometimes grazing management is enough. But yeah, you need to have that strategic approach. And just this last slide, there's a lot of words on it, but basically before we approach any sort of project, these are the steps that we go through. So Hugh's got a program, a planning program under that ecosystem management understanding, where each project that we do goes through these sort of steps. You know, is it the best problem to fix? Why is the problem there? What impact is this problem having? What do you want to achieve by fixing the problem? And once all those questions are answered, then that's when we go to that technique, the toolbox, as it were, to fix the problem. And sometimes it could just be grazing management. Sometimes it could be big banks, and just whatever the toolbox is. So that's why we've got Hugh sort of working in conjunction with us at the moment, just so we can be a bit more strategic about the rehabilitation that we do out here in Western New South Wales. So that's pretty much my talk. Finished. So do you want me to go through anything else, or
No, any questions there? Or any comments, discussions? Come on, everyone, there must be some comments there.
That's all right.
You know, Paul, yeah, you know, Jeff here. No, it's interesting the issues you're facing in New South Wales, and you know, I can apply a lot of what you talked about in my situation, and it's certainly backed up some of the Stuart Andrews stuff that we've learned and already implemented. So, so both, thank you to both of you. It's interesting to have that supporting information, I guess.
Yeah, Paul, it's Bruce Alchin here. Just a comment you made on your water spreading banks, that they couldn't handle high flows or strong flows. Some of the early banks that were put in around the Cobar district were handling flows that before the earthwork put in, they were over 1 metre high, coming down the flat between the ridges. So I just, yeah, wondering why you made the comment about the water spreading banks not able to handle strong flows.
So that one there, is that the Aroma example? Because there are some water spreading systems that are massive. They've been built with bulldozers, and so they can handle some pretty big flows. But I've just found that from a cost-effective point of view, like, we're not building them with bulldozers, we're building them with graders. And just because of the money side of it, and when you're building them with a grader, the banks are slightly smaller and the channels are slightly smaller. So yeah, they're not handling, you know, massive volumes.
Yeah, this was the early work in the Cobar Burke area, and most of them were done with dozers. You're quite right.
Yeah, no, that's the only reason. But yeah, they can handle lots of flows. But I suppose I'm being a little bit cautious as well.
Bob, have you got any comments in relation to the region?
Sorry, who was that?
Bob Shepherd is coming on board.
Thanks, Anne. I guess a couple of things from observations in the northwest after the floods last year, and I had 2 trips out there in June and September. I visited, I think it was about 18 properties, which was a very small percentage of the properties that were affected by the floods. But I'd like to, I guess, reinforce Paul's point about grazing land management. And prior to the flood, with 4 or 5 years of very low rainfall and drought, I mean, I'm not a grazier, but I realise it's very difficult to maintain good ground cover level and protect and manage tussocks so they survive during a drought that's 4 or 5 years. But some landholders did manage to do it. They obviously got rid of stock very early, The tussocks were there during the flood. By and large, the erosion was a lot less serious on those properties and in those paddocks. The tussocks appeared dead, but by June, and things had well and truly dried out by then, it was surprising how many of those tussocks did put a green tiller out. Now, I guess the fact you've had another lean season this year after that big wet last year, I'm not too sure how many of those tussocks have survived and continued to actually grow. But it certainly made a huge difference to the erosion damage. And you could see it didn't matter whether it was on floodplains along creeks, whether it was just in paddocks where there's broad overland flow, it really slowed the water down. And I mean, you can look at the hydrology of it and the hydraulics of it, and the water velocities, even with a fairly rudimentary amount of ground cover and a fairly small density of tussocks, is diminished quite a lot. So erosive velocities in water are dropped dramatically by having, you know, even not even a huge amount of cover there and not even a huge amount of tussocks, but you do need something. And that was probably the standout for me in those 2 visits out there last year, yeah, the grazing management before the flood made a huge difference.
Thanks, Bob.
If I could just make a comment after Bob there, Scott.
Yeah.
Is that coming through here?
Yeah, no, go ahead.
Yeah, just following from Bob, I understand that's tremendous, and we've been doing a lot of trials over a grader for 30 years, so I suppose 30 years, or a little bit prior to that with a little scarifier behind a tractor. We had areas
Hang
on
on, just
previous
stop. Can you just come a bit closer? You're dropping out a little bit. Yep.
Is that better?
Yeah.
We had a lot of scalded country that we buffel grass and summer grasses to grow on. But unfortunately, with the crazy event that we had at the beginning of last year, we lost most of that, and those areas just eroded out enormously to the fact that they held water for 4 or 5 months. And then we had black soil areas where roads were put in the 70s when a bore was put in, both coming to and going away from the bore from the house, in the vicinity of 5 to 7 kilometres, and those there got up to 4 metres deep, and that's the first erosion we've had on those areas. And we're a little bit we haven't had a chance to get at it because we've had other things we've had to contend to, but we want to do some repair work to those areas, but we're a bit concerned where we're going to get the soil from and make it work without making the whole thing worse. They were big black soil flats that obviously had, in areas, close on 2 metres of water over them in this last flood. Normally would only get a couple of feet at its peak. We're just at a bit of a loss how to handle some of those spots. They're so long and they hold water. For, one that's only just dried up now, and we only had 1 rain event here in February this year. So they're quite big receptacles. We'd like to do something with those, and if somebody had some suggestions.
You're dropping in and out there a little bit, Scott. Did you?
Maybe it's our internet.
It kind of comes and goes a little bit there. Did you hear most of that, Paul? Or Bob? You?
Yeah, I heard it.
Any comments? Scott, when Daryl Hill does come to the region, I've got Bernard on the list to visit, to go and have a look at, you know, some of your problems there.
Scott, just
thanks,
I haven't seen your problems on the ground, but I look at that last slide that Paul's still got on the screen, and they're probably the questions I'd be asking myself with erosion problems like that. I mean, at the end of the day, they're probably going to be quite expensive to fix up. You could try some low-cost methods, similar to what Hugh mentioned during his presentation. But at the end of the day, are they the best place to spend the dollar? Or is the dollar better spent doing something else on the property, whether it's reclaiming land or whether it's other infrastructure or whatever it is? Because they can be a bit of a bottomless pit, those big erosion problems, particularly where they're that deep. And I think you said even in a normal year it would have, or an average wet season, it would have probably 2 foot of water over it, whereas last year it had meters over it. So there, I'd probably go through those questions that Paul's got on the screen there and make a call on whether that's the best way to go, or whether there might be another half a dozen other things that you could consider on the property. Thanks, Anne.
One of the key issues there, I think, with Scott, with one of your main problems is that main roadway to your yards, isn't it, Scott? Is that one of the...
That's correct, and we've had to build a new road to get out to the yard, which wasn't really a problem. To build it obviously was an extra job to do, and the road that we have replaced has been used since 1974 with just general maintenance and hasn't created a problem until this year. And obviously, if we're going to do something, it's going to be very expensive, like Bob just said, and it's fairly well down our list at the moment. But just so I'm listening here today, I thought somebody might have a bit of a silver bullet.
Yeah, and it's more there. You've got a new channel, you've got a new drainage line, haven't you?
Well, one of them 7 kilometres long, and it's just very similar to the photograph that's right at the beginning of the presentation here tonight. But it's virtually dead straight, and one goes for 7 kilometres. And in April, end of April this year, there was 5 kilometres of water still in it.
And I'd just like to add a couple more things, particularly about roads. Paul covered the methods of fixing up roads really well, and it's good that Paul, you also mentioned about location, because some of the problems I saw when I was out there, particularly in September, one property in particular in the Richmond area that from the bitumen road to a set of yards was 5 kilometres, and the road just went straight like a gun barrel. Uphill, over dale, sometimes following a part of a drainage line, seldom if ever on a ridge. And it turned into a mini Suez Canal. And I had a look around with the manager of the property, and I said, look, you could spend a lot of money fixing this up. I said, there's some ridges around here, very subtle, but they are ridges. And basically they relocated the road on a ridge, which instead of a 5 kilometre or 4 kilometre direct run, it was about 6 Ks, but it'll be a road that'll be easy to maintain, and it'll be trafficable most of the time. So I think location is a big thing, particularly when you've got badly eroded roads, to say, well, do we put it back in the same spot, or do we look somewhere else and see what the other options are? Thanks, Anne.
Yeah, thanks, Bob. Anyone else got any comments?
Anne, could I
Question?
make a comment?
Yeah,
Can you
go
hear me?
ahead.
Yeah, can you hear me, Anne?
Yes, yes.
Okay, yeah, just adding on to this discussion. One other question you might think about is what is the cost of doing nothing? And that's very rarely contemplated, but it's actually quite important, and it may end up leading to different priorities. The other thing is that, and I think Cape York NRM was involved, is that Paul, Daryl Hill, and my mentor, Cole Stanton, and Russell Grant, who got me to New South Wales to build some strategic planning into the rehab program. We put out a national little booklet on managing outback roads. That's got a lot of what we're talking about in it. And it's basically been structured for pastoralists. So lots of diagrams, pictures, and so forth, and not much verbosity. And that might be worth thinking about.
So, Hugh, is that booklet in print, or how do we acquire that booklet.
Yep.
Yeah, we've got a whole heap of them in our office in Cobar. I can send you some, Anne.
Oh, that'd be great.
Yeah, but yeah, like Hugh said, it combines a lot of the techniques that we've been talking about, not just, you know, one. So yeah, I'll write that down and send you a box or whatever.
Oh, that'd be brilliant. Thank you.
Hi, Anne. Can you hear me?
Yes, sorry, who's that? Oh,
Yes,
John, is
John, Anne.
it?
I just wanting to say that what we probably lack up in this part of the world, and whilst we have, you know, Daryl has made, you know, several trips, he makes a couple a year down this way, and we have Bob over in Charterstown, but we actually lack someone similar to the two men who have been talking to us tonight, that that can actually plan and design a whole system for some of us to sort some of these problems. That's, yeah, in my opinion, we need, there's people who are listening tonight on the webinar that are keen to do something. They just lack probably the expertise to go that next step.
Yeah, I agree, John. And that's it. Like, it'll be a matter of, we can identify that as an NRM organisation, and possibly, you know, seek funding if opportunities arise, if there's government offer any projects that are targeting that sort of thing. So we can certainly be considering that. And I know, like, you've got some dramas there following last year's flood as well. So yeah, so I know that you do need some help there with what you've got to deal with. Yeah, but that's certainly something that we're aware of, John, and we could be maybe bringing some people up to see what we can do about that.
No, that'd be good, because yeah, I think we just need that advice, and that it's all good to look at it's great to look at all but to actually implement that is another you know, step again, really, isn't it?
Oh, absolutely.
And could I make a comment?
Yes, Hugh.
I think John's spot on, and that's a problem all over Australia, and that's why people like Daryl and Cole Stanton and I have lots of work, and we're spread pretty thin. The long-term solution is what John said. You guys need your own local trained up staff, and so people like Paul, Daryl, Cole, and I shouldn't be just going out and doing contract jobs. Part of that should be capacity building, and that's the key of EMU, is to build in your own redundancy. You guys need to become self-sufficient in soil conservation with a soil con officer, but also a soil con community, so that you have a local knowledge network functioning. And that's the long-term outcome that I suspect you guys should be aiming for, not just to expand your budget and your dependence on outside knowledge.
And it's acquiring those skills. I mean, that's part of the problem, is finding people that have those skills. And when one that we have not far out of the region is semi-retiring, makes it very difficult, doesn't it, Bob? And it's hard enough to get him into the region as it is, because his services are required elsewhere, where they have more funding dollars.
It's a very good point, Hugh. It's highly valid. And like Anne said, I'm spread like Vegemite across Queensland. And I run a couple of workshops with other semi-retired soil conservation or ex-soil con staff, and for NRM groups, mainly in the Burdekin region and the Fitzroy Basin, and also down in the Burnett Mary area. And we run a week workshop, and we try and give those very keen and enthusiastic young staff 4 years worth of knowledge and information in 1 week. And of course, all you do is you're really giving a little knowledge, which is a dangerous thing. So it's a real challenge. And I think, you know, that capacity building in the local area is absolutely crucial because, you know, I look at the age of the people that are on the teleconference tonight, and yeah, we're not spring chickens, most of us anymore. There's a few there that are. I see Colin Burnett, I know Cole well, he's a young fella, but yeah, big challenge. Thank you.
So, yeah, am I unmuted?
Yeah, no, you're unmuted.
Yeah. So we've been since 2016. We've like the Western New South Wales had this rangeland rehab role for a while now, but since 2016 we've been really trying to get that what Hugh was talking about. Like we've gotten Hugh on board, and there's been about 16 properties. They're all neighbouring, and trying to build that local network. And within that group, there's some really good operators now that have really understood the concepts, and they're actually become sort of like the local consultant in a way. Like they've you know bought machines themselves and doing the local jobs, and yeah, the capacity building is really growing. Really, yeah, it's doing Hugh out of a job in a way. Oh, you know, in a small way, because there's plenty of work left. But yeah, it's really working that model in that White Cliffs area. So yeah, it is good to see. It can happen. Yeah.
Well, and one of the good things about tonight is we do have, and I forgot to acknowledge you both earlier, we do have two of our Southern Gulf NRM board members in the session as well. So Ray Campbell, who's hiding away there, and Roger Hill. They're both on our board. So, you know, down the track that, you know, possibly it could be something that the, as an NRM organisation that we look at. Roger, Ray, do you want to comment at all?
Yeah, certainly. And thank you very much to yourself for your work tonight. I think that's the one that you're the person that needs the praise. And one of the things that we need to look at, and the building capacity is a core thing that the board has actually been investigating, and we really are having a look at that. Then the on-ground skill bases, like to see some of the people that, and I noticed Bob mentioned Cole Burnett just before, but there's Jeff Waring sitting on board. You're getting your local incubators, they are developing here. And so by keeping to these fellas working, they're going out, they're talking to their brothers, they're talking to their neighbours. We're at a very incubator, early adopter stage, I'd suggest. We'll keep working on it.
Mm. That's it. Very good. Any other questions?
I can totally agree with Roger, and thanks very much, Anne. And
oh, you're hiding away there, Ray. We can only put you
yeah. But it's been a great show, and it's great to see so many people zooming in, and keep up the good work. And we'll definitely see a lot more of this erosion problem. Yeah, it's very good. Thanks very much.
Thanks, Ray. And we have got other people that couldn't make it tonight. That's what you know. They want to listen to the recording, watch the recording. So thank you. Does anyone else have any other points to make?
I just wanted to go back to Scott's example, actually, if that's okay. It's Peter Irish here, and Hugh's comment just about, you know, the cost of doing nothing. And I was just wondering, I didn't get a really clear picture in my mind about exactly what was happening on Scott's Place, but I just wondered, you know, where you've got a situation where you've had one season or one flood event that's created something, and then it's sitting there, you know, and then what's going to happen next? And I guess I just wondered, you know, we talked about how, you know, perhaps it'd be quite an expensive fix, but, you know, is there situations where you might sort of assess the potential damage next wet season and decide, look, we can't afford to fix this, but, you know, perhaps we can afford to put in, you know, some sort of diversion perhaps, or whatever's appropriate, which might be relatively cheap, and just to, you know, prevent that potentially serious damage, you know, happening next time? Is that something to think about for perhaps for Scott?
Yeah, and unfortunately Scott's left us, I think. But yeah, that's certainly something for him to consider. And I have lined up Daryl to go and call in there. And Bob, if you're ever back out in the region and have time, it might be worth you having a look too. And like, he is a very good land manager, very, you know, they do have very good grazing management. And he, you know, they've always got plenty of grass, so it wasn't through lack of grazing land management that caused the problem. It was just the quantity of water. Yeah, and it's similar to the photo that was on the front of the flyer. It was an area that also had good ground cover. You know, they'd left, you know, a considerable amount of you know, of tussock length and thick, you know, dense tussocks, and it was just a bit of a dip in the, like, along the, you know, the Mitchell Grass Downs area that just had a slight dip, and just the amount of overflow water that just washed it out and created that gully. So yeah, but I'll certainly chat to Scott about that. So thanks, Peter.
Hi,
Anyone else?
Anne, can I chip in?
Yes, Peter.
Yeah, I just had a question in the chat box regarding those drill rod lines in the creek. I couldn't really tell from the photos whether was it just vertical drill rods, or were there some sort of horizontal bar or something going along that also helped hold the debris up?
Did you want me to answer that one, Anne?
Yes, please. Sorry, and I'm reading the chat there. Sorry, Anita. Yeah, no, that's, yes, please do.
Yeah, no, thanks. Good question. There was nothing put in place in that case, and the one that we did beforehand on the same property, we stacked some branches and so forth, and then the pastoralist just laughed at us, and when he'd done his version of it, and just said there's absolutely no need for any additional barrier to speed things up. There's enough stuff coming down the creek, and if there isn't, I'd do it without anything. And if that's not good enough, then you could worry about putting in some filtering between the rods, but don't do it from the outset. See if the rods on their own are good enough.
Thanks, Hugh.
How far in the ground, like how far are you putting them into the soil?
Those ones were on a rock bar, and we recommend that you do them on rock bars. They were about 1 meter deep into the ground, drilled in. And one other thing to think about is protecting the sides if you've got soft sides, because they will blow out the sides if you don't protect them. And also try and make it so that the water is drawn to overflow in the center. So you can either curve them a little bit downslope, or you can make them lower in the center to take pressure off the sides if you've got soft sides.
Yeah, radio. That had crossed my mind where the water was going to go otherwise. But yeah, we've got a lot of prickly acacia here, so there's plenty of debris to stack up against things.
Thanks, Anita. Anyone else? How are you going there, Cole? We might have lost him.
Hi, Anne. John here again. I just had another question.
Yes, John.
You or Paul, with the nick points, like we can counteract a road with a woo boy or a culvert, we can work on that. But with the cattle pads, what would you suggest? Like, they're inevitable, unfortunately, but yeah, and when something starts developing along them, what's the best way to to try and solve that? Do we just put little banks across them to divert the water back to where it would have gone? Is that the best way?
You can talk, Hugh.
Okay, thanks, mate. Firstly, they're not inevitable. Pads are the result of your grazing strategy and the location of your watering points. There are a couple of properties that I've worked on that have no cattle properties, that have zero pads, or at least not permanent ones, because they do a rotational grazing system, very slow rotations. So, and basically the cattle pads become the fertile patches for the recovery period that follows the grazing period. So they're not inevitable. You don't have to have them. Even in one property in particular, Bob Purvis's place near Alice Springs, they're not even there at the watering point. And the other thing, of course, is the location of the watering point. If you put them in the bottom of the valley, yes, they may be inevitable, because that's where the water will find them and work on them, because the water in the compressed cattle pad becomes what they call macro turbulent, so basically just fast and angry. So in terms of fixing them, I think you'd go mad trying to deal with every cattle pad on your property. I'd only deal with the ones that have the potential to create major gully systems in your bottomlands, and even use diversion fences, which we've done on one property in the Murchison, just in fragile bottomland country, and it's flood out fan coming off the valley side. We just put check fences, brightly coloured up, so that the workers don't run into them when they're mustering.
And could I add something to that too, please?
Yes, Bob.
Anita mentioned about, there's plenty of prickly acacia. I mean, most properties now have got a certain degree of prickly acacia on them. You can just cut a fairly big prickly acacia tree, preferably when it hasn't got seed on it, and just drag it and put it on some of these cattle pads where they are presenting a problem. Cattle will soon walk around them. And even if you put 2 or 3, they'll walk around it enough that there's a chance that the water will go off a new cattle pad rather than cutting a deep new cattle pad. So you can do that. It's a bit of mucking around, but it is feasible. I've seen it done with brush and that sort of thing too.
Yeah, good idea. Have we got Cole there? Cole, did you have any questions? No, I thought I saw his audio come on. Whereas Phil's there, but he can't, hasn't got a mic. Rachel, did you have any questions?
No, and thank you very much for the presentation. I don't have any questions, but I just wanted to give a bit of a shout out to our NREP project, which has, we've got some funding available coming up in the next couple of months. There's some expressions of interest out there, and it has a pretty big component on waterway and sediment management and erosion control. So I don't mean to hijack your session, but if anyone's interested, there is the expressions out there. So some of that funding is well and truly on the same path as some of our discussions tonight. So it's fairly generic. Yeah, and if anyone's interested, let me know and we'll get in touch with Anne and we can certainly have a chat.
Thanks, Rach. I did mention that to John's wife, Susie, the other day when I was there. John wasn't there, but yes, hopefully she's mentioning that to you, John. And the only one I haven't discussed it with previously is Phil, although I was thinking of taking, I know Phil had originally talked about getting Daryl to visit at some stage. So yeah, so keen to go and see what Phil's got going on there. So yes, so I'll have a chat to you about that later, Phil.
Thank you, Anne.
Thank you. Anyone else like to make any points? I'd like to say a big thank you to Paul and to Hugh. Really appreciate the time you've given. And thanks, Bob, for your contributions. Really appreciate that since you've got the local knowledge. And I'd just like to let everyone know at this stage with Daryl Hill, we've kept putting him back. We did have him booked for April, then we were deciding on June, then made it July. And at this stage, we're hoping for August. Hopefully, we've heard that hopefully that the territory border restriction will be open so that we can, Daryl could come into the region. So as soon as we can, we'll be doing a series of field days and some property visits, some on-site visits of, problem areas. And then down the track, we'll just see how things go after that, because maybe we do need to be looking at other, bringing other, consultants into the region. So thank you. I really appreciate everyone giving their time this evening. And I know we've gone on, much later than 8 o'clock, but really appreciate the time that everyone's taken to participate. But a big thank you to Paul and Hugh. Really appreciate it. Thanks.
No worries. Thank you.
Thank you, Paul and Hugh.
Thank you, Anne, for setting everything up.
Thank you. And we managed to get by. We're all still learning on this, but on Zoom. But yeah, we seem to be getting by. And I'm really glad that everyone had the opportunity to interact, because to me you learn so much more when you can ask the questions that are that of issues that apply to you. So thank you. Oh, Helena, you've been very quiet there. Sorry. Any comments there? No, she's keeping very quiet. Okay, well, good evening, everyone. Thanks very much.